So the first one is calculate the acute angle. Because you're given that, you see this one parameter t0, they give you the housing address of A is t equals to 0. So essentially when t is 0, the OA, that would be 1, 2, 3. Oh, it's just 1, 2, 3 lah. Because this is 0, right? That's OA. So you want to find acute angle between OA and L. So this case here, this is L, this is A, and this is D direction. Minus 1, 1, 1. All right. What to do next? You want the angle between them. Say this is O. Yeah. Okay. So what you do is if you want the acute angle, I'm not sure where they are pointing at, but what you can do is if it's acute, just modulus it. So this case here, you get 4 over square root 14. They want nearest degree, so don't leave it in 1 dp. This will be 52 nearest degree. Acute angle. So if P is on L, such that OP is perpendicular to L, if P is on L, means P will satisfy the line equation, okay? So without any doubt, right, it's just for since, okay, P on L, right, means P satisfies the line equation, okay? Meaning there's one particular T, which is the housing address, will correspond to the line equation. So for some P real value, you just write OP. Now you have OP as a line equation. It's very convenient because you can use this as your the way you solve things. Okay, so you just use this one. This is where T is here. OP is this value here. You are told that P on L such that OP is perpendicular to, so OP, let's say P is here, then O is here lah. Okay, this is perpendicular. So this is OP. Your goal now is to solve what is this T here. Okay, in order for you to solve what is this T, because once you have this T, you can solve what's the coordinate of P. So like I said, you just need to know dot product, cross product, and magic triangle. If this is 90 degrees, you for sure, if it's 90 degrees, cosine 90 is 0. You know that the dot product of these two will be 0. Understand? So essentially, since it's 90 degrees, so you know that OP dot with D will be 0. Dot product is 0. Foot of perpendicular. So since OP perpendicular D, so this is what I get. I will get 1, 2, 3 plus T dot with minus 1, 1, 1. Then same thing when you dot it, you start off like that, like that, like that. Then you dot the other side. Okay. So I dot the first one first like that. It'll be minus 1 plus 2 plus 3 plus T dot this. Minus 1 times minus 1 is 1. 1 times 1 is 1, 1, 1. Very good. So I got the housing address for P. So hence OP will be 1, 2, 3, negative 4 quarter, minus 1, 1. Do they want the coordinates or position vector? Okay. Oh. Point Q is on L. Same thing for some lambda T. OQ will just take the line equation. 5 units away. So I'm not sure how it look like, but this is Q, like this is O. So we're told that this is 5 units away. So this is obviously not the only time where it's 5 units away. The other one is you could be on this end also. So Q1, Q2. Okay, the idea is just to, if Q satisfy the line equation, you just say for some T real value, OQ will just take the line equation. Then you solve it using this line equation. 1, 2, 3. Okay, that's it. Then okay. Basically, since OQ given that OQ is 5, so this will tell you that mod OQ is equals to 5. Then you just solve it. Just solve it. Modulus will be square root equals to 5. Where both sides are t square minus 2t plus 1 plus t square plus 4t. I will advise you to just arrange like that lah. So if you see this kind of question, just arrange the t square and the t and the constant together. Be quite okay. Maybe I just put the square root out of first before I square both sides. This will be 3t square. It's 8t plus 14 equals to 5 square. So this case here we'll get is 3t square. This is 0. There will be so once done, you get a t, sub back into the line equation, find your OQ, two possible position. So this will be your OQ. You sub back into the equation, you get Q, this one or this one. Okay. Let's look at the last one. Last one is what I want to tackle. The fourth part is what do you want to show? Okay, let's say now they say that R with this housing address and S with this housing address. So if R T equals lambda, now they want you to show that OR and OS are there are no value of lambda which they are perpendicular. Meaning to say, want to show what? OR dot with OS cannot be equals to 0. Okay? If there are no lambda, you just follow what they say. So essentially you want to show that the dot product cannot be 0 because there's no value of lambda. There's no housing address which will correspond them to be 90 degrees. So you just let for when t equals to lambda, that will give us OR, the position vector of R, which is 1, 2, 3 plus lambda minus 1, 1, 1. So when t equals to 2 lambda, OR, OS is just be 1, 2, 3 minus 1, 1, 1. Okay. Essentially, what they are saying is if I've got this is lambda and this is 2 lambda, I want to show that this guy here, this is OR, and OS, when it dot, it will not be 0 because this will never be 90 degrees. The idea is because this guy is twice of this, is dependent. So no matter what you do here, this one will twice of it, the housing address. Okay. So we just take OR dot OS. The entire OR, now this is the entire direction vector. 1, 2, 3. Dot with OS. Okay, this one. plus 3 lambda. Usually, I would advise once you expand, you try not to work in one line because you can align them nicely like that. Then it will be much easier. So this one here is what I get. What you do is you, aiyo, complete the square. Anything quadratic, you complete the square, best game. Okay, I think completing a square is easiest, at least for me lah. I mean, just practice completing the square. So lambda plus 1 square. You just want to show that it's always positive. So I think this one here will just be 14 plus 6 lambda plus 1 square minus 6. 14 minus 6 will be 8. So there you go. It's always positive. So since OR cannot be 0. Okay. Then wow, such a long. So there's no value of lambda for which they are perpendicular. OR dot rest are perpendicular. So that's how you show. You show that it's always positive. Then you know that for all real value lambda, real value OR dot OS cannot be 0. So there's no value of lambda for which OR and OS are perpendicular.